Okay. First, this is the data, sample data. I'll explain you the overall approach. Again, we will go to the code. First, get this overall data. Now, to solve this problem, first of all, we cannot directly take the words as it is to build the model. We need to convert them to numbers. So here are the list of unique words. Intentionally, I took a smaller data set to understand the concept. Later on, we are going to take a really large data set and work with it. But here, to understand the concept, I took a small data set. There are only 139 unique words in the whole data. There are 139 unique words are there: a, about, able, admit, affection, all, and other, like that, love, etc., etc. These are all the distinct words overall. Now we are going to create two dictionaries. What are these two dictionaries? The first dictionary will be taking words as keys, numbers. So first dictionary will map the words to numbers. Obviously, we have to do this because we have to do the analysis on the numbers. ANN cannot be built on the words. ANN cannot understand, or any of these mathematical machine learning, they cannot work on non-numeric data. We have to map them onto numbers. Okay. First dictionary is mapping the words to numbers. Once you are done with ANN, finally we cannot give the numbers as the output. Can you give number as output? No, you have to give the word as output. That means you have to build another dictionary that will be from numbers to words. Look at this. A is key, 0 is the number associated with it. Able is key, 1 is the number associated with it. Just the opposite of it will be another dictionary. A will be the value, 0 will be the key. So this is the first dictionary. This is the second dictionary: 0 to A, 1 to able, 2 to about. This will be done. This will be used in the prediction time. Look at this, all of you. This will be used in the prediction time because prediction from ANN comes in terms of numbers. Numbers cannot be given to the user as the final output. Numbers to words should be done. This will be used for model building time. A 0, able 1, about 2. Okay, these are the two dictionaries. We cannot actually map like this. When you have words, distinct words, when you have 139 distinct words, shall we map them to 0, 1, 2, and so on 138, or is there a better way to do it? Do you remember how do we map words to numbers? If you have region east, west, north, south, shall we map them to 1, 2, 3, 4, or we have a better method? Do you remember the method that we use when you have prime, non-prime customers? Do we map it like if you have prime, non-prime, or extra prime, 0, 1, 2? Shall we do it like this, or is there a smarter way we do it? If you remember, if you have 139 distinct words, you need to do one hot encoding. That's right, one hot encoding. So we are going to do one hot encoding, which means if you take one, so since there are 139 distinct words, one column, like one particular column, which is word 1, will give us how many new columns? Tell me. Word 1 has different values. Let us suppose, if we go back to our previous example, region has east, west, north, south. One column region will give how many new columns? 4 new columns. Now word 1 has 139 distinct words. How many new columns word 1 will give you? 139 columns when you do one hot encoding. Do you understand that? Word 2 again has 139. How many new columns will it give? How many new columns will it give? Again 139. Have you understood that, all of you? Because these are words. Words cannot be directly used. Words need to be mapped to one hot encoding. Then you do one hot encoding. Then one column will become multiple columns. That is the reason why, if you see word hate, somewhere it will be 1, remaining all will be 0. Word love, somewhere it will be 1, remaining all will be 0. Have you understood this, all of you? Let me show you in the code file. Okay, let us go back to the code here. So here first I am mapping words to characters, characters to words. After that, we are mapping it to one hot encoding. Look at this carefully. Okay, some of the examples. Yeah. So there are 139 unique words are there. Okay. Now here is the X data. Look at this, all of you. X data, gram2 is the data set. Gram2 is the data set. I'm taking word1. Then using keras util two categorical. In pandas, do you remember get dummies was the one hot encoding function. Here in keras, two categorical function will be used. Okay. Number of classes equal to length of the character to indices. Number of classes are 139. So what will be x1 shape? Can somebody guess the x1 shape? There are overall in the data, there are 5351 rows are there and 3 columns. One of the column is our word one. Now what will be the shape of x1 before even if we execute this? Can you guess the shape of x1? Number of rows and number of columns in x1? Make a guess. What will be the shape of x1? 5351 rows will be there in x1 because rows will remain as it is, and x1 is word 1. How many columns will be there? One column, which is word 1. 139 columns will be there. Similarly, y is our output, which is word 2. First ANN model, what did we discuss about the first ANN model? We will take word 1 as input, word 2 as output. So what will be the shape of y? What will be the shape of y? 139. So let us check whether our understanding is right or wrong. 5351 rows, 139 calls in x1. 5351 rows, 139 calls in x2. All of you, are you on the same page? Do you agree with this? Word 1 is the input, but one word, one column is now 139 columns because these are all one hot encoded. Word 2 is the output, one word, which is one column, is 139 columns. So if you want to see an example of this, one of these words, you can see them. Like one hot encoding is very simple. Everything will be 0. If you take hate, that will be corresponding to a particular column, that will be 1, remaining all will be 0. If you take love, that somewhere else will be 1, remaining all will be 0. Okay, are you with me? Now let us build our first ANN model. In this first ANN model, look at this model sequential. This is usual ANN model. I am building dense 10, and then input dimensions and output layer. Can somebody tell me, help me in finishing or completing the architecture of this? Dense 10 is what you need to remember from here. So let us draw the architecture of this. Okay, input has how many layer, how many nodes? Input layer is x, which is word 1. Hidden layer, then word 2 is the output layer, which is y. Input has how many nodes? Input layer has how many nodes from this code? Tell me. How many nodes in the input layer? Nodes. Think about the nodes, number of nodes in the input layer. Is the number of rows end up as the number of nodes, or is the number of columns? Is it 5351 or something else? Think about it. How many nodes are there in the input layer? How many nodes are there? How many ever columns? Like word 1, we have word 1 has given how many columns? 139. 1 2 3 4 and so on, 139 columns. So there will be 139 nodes. Do you agree with that point? Think about it, all of you. Is it the number of rows or the number of columns that will end up? Let's say you have 5000 rows, but you have x1, x2, x3. Then input has how many nodes? Input layer has 139. Hidden layer, we are giving them in the code. Hidden layer has how many nodes here? How many have we mentioned? H1, H2 and so on. How many nodes? 10 nodes. All right. Output layer, which is happened to be word 2 in our case. How many nodes? How many nodes in the output layer? How many nodes in the output layer? Y is word 2. How many nodes are there in the output layer? Again 139 are there. So that is our first ANN model. I'm not really interested in the final output here. I'll just build the model. And what I'm interested is the partial output of this. So here is the model building process. But you know what? I'm not interested in the final accuracy or anything. I'm not interested. I'm interested in a particular thing. Look at this, all of you, carefully. Look at this. What we want to do is we want to build ANN 2. ANN 1 is already built. ANN 1 we have already completed. What we want to do is, this is ANN 1. We have 139 nodes here, 10 nodes here. We have around 139 nodes here. This is word 1. This is word 2. But next time what I want to do is, I want to build ANN 2. ANN 2. I want to take this hidden node output. That means I want to take this 10 node output for every data point. How many data points are there? There are 5, 3, 5, 1 data points are there. For every data point, I want to get H1, H2 and so on H10. They will be almost like 10 variables. Every data point, every new data point, I want to get the partial output only. Usually our regular exercise will be for every data point, you get the predicted value. However, here we are interested only in the partial output value. What is it? Hidden layer output. Take that, append it to the word 2. Again, word 2 has 139 nodes. Again, we can build it with 10 hidden nodes. This is ANN 2 that I'm talking about. Again, word 3 has 139 nodes. However, this appending, how it is done? Here is the logic. So first, get this partial output. All of you, look at this partial output. I'm not going to the final output. I'm just taking the weights. I'm taking only weights from layer 0. That means the first layer input to hidden layer, and then get the partial output. Since there are 5,000 rows, for every single data point, you will have 10, 10, 10, 10 values. You know how that will appear? When you predict this only partial output, it will appear like this. Hidden layer output for every record. Check this out. Since there are 10 hidden nodes, it will be almost like 10 new nodes or 10 new columns values. This is the partial output. This is how we take only the partial output. Now what are we going to do this partial output? We are going to append it to word to build model 2 here. So check this out. The next one. Look at this. This is ANN2 starting here. Please focus on this, all of you. ANN2 starting. This is actual word 2 x2 underscore 2. For ANN2, this is going to be input 5351 comma 139. Is this clear? This snippet why it is 5351 comma 139. This is simply word 2 one hot encoded values. Here is the appending. Check this out. Appending h1 x2 underscore 2 axis 1. That means I'm appending them side by side. X2 underscore 2 has how many columns already? What is the dimensionality? Can you make a guess about the dimensionality of the final x2? Can you make a guess about the dimensionality of the final x2, which is after appending h1, which means partial output from model 1, as well as input for model 2? 139 plus 10 more nodes, which will be like 5351 comma 149. Agreed? Number of rows will be 5351. For every row, you have 139 one hot encoded values and 10 hidden node values, 5351 comma 149. Look at this. Word 3. Word 3 is the final second model's output. So for the second model, you will take y2. What is the shape of this? 5351 comma 139. Now, this is the second ANN model. First ANN model done. First ANN model completed. Partial output of first ANN model considered. Now, second ANN model is built. While building the second ANN model, we are taking the partial output from the first ANN model. We are giving it to the second ANN. This is the second ANN model. Okay. Check this out. This is a second ANN model. In this model, we are taking the x2. But you know what? While we are creating x2, we have appended partial output as well as word 2. That is the reason why there are 149. So this is what we have done. This is ANN1. This is ANN1. Then we took this. And ANN2 is this appended to this. This is overall ANN2. ANN2 shape and all that. Build this model. So we build two models. However, when we are building the second model, carefully we took the partial output from the first model. Hey, why are we doing all this? Why can't we keep it simple? Why are we doing all this? Because this is sequential data. We want to go in this particular sequence only. You cannot disturb this sequence. You cannot take word 2 first, word 1 first. You have to go in that particular manner. Even for the prediction, you know how the prediction will happen. Prediction is also a big task. The reason for that is, first you have to take, let us suppose our new input, somebody want to predict anything, he will give word 1 and word 2. We have to predict word 3, right? So in this approach, what we need to do, first you have to take word 1 as input, supply to the ANN 1, take only partial output, hidden node output, then take word 2, append it to word 1, then only you will get word 3. Are you getting why are we doing this? Because we want to take this sequence, we want to give preference, we want to give respect to this sequence. So that is the reason why we are writing a new predict function, which will take word 1, get the partial output, append it later on, then use it in the next output. Okay, let us execute this. Then finally you will get the predicted values. Go ahead, execute step by step everything, and tell me the predicted values for those 3 examples. Okay, go ahead, execute all these steps. As I told you, even if you do not follow the code, that is perfectly fine. There is a shortcut way to do this that I'm going to introduce later on. This is to understand the concept only as of now. Go ahead, execute this, everyone. What are your predicted values? So get the predicted values for those 3 examples that are shared. So what you will see is, if everything works fine, once you execute this as well as the next one, love it when. So basically it is showing some deprecation warning and all that. You can ignore all these warnings. Love it when is the prediction. I think later on some of these functions, they are getting deprecated. That's perfectly fine. Next one, love to. Love to also predicted as when for some reason, and love the when. No, there must be something wrong. Let us re-execute this once again, one by one. Make sure that we did not miss anything. Executed, partial output taken, built the second model. Okay, model building, and then a bit more epochs, maybe 40 epochs, trying to increase the epochs, try to see whether the accuracy will increase or not. Slightly better accuracy now. Maybe with this one, if we execute, love it when, love to see, love the way. So maybe with 20 epochs, I did not get good accuracy. You can increase the number of epochs to 40 or 60. Slightly better accuracy is what you will see. Then when you execute this, I got love it when, love to see, love the way. These are the predicted values. Again, the prediction totally it depends on the way the data is trained. It depends on what input data that we have. Depending on the input data, we got the predicted values, love it when, love to see, and love the way. So what we did is we manually created two ANNs, then we combined them. Have you understood how we combined them? Since we are working with three words, we created ANN1, that is X1, H1, Y1, then X2, H2, Y2. However, when I'm predicting this second ANN model, some partial output from here is taken and then appended to this one. This is known as sequential ANN model. It works perfectly when you do it this way. This is the solution for our problem.